Hi there, and welcome to our lecture on temperature. This is Heat 1. Our key ideas: what does temperature have to do with energy? What three temperature scales are commonly used? And what makes things feel hot or cold? So to start looking at this first question, the temperature of a substance is proportional to the average kinetic energy of the substance particles. So how fast those particles are moving is basically just an average of how or what the temperature is of an object. So we can define temperature as a measure of how hot or cold something is, and then we're specifically measuring the average kinetic energy of the particles that are in that object. Alright, so all particles have kinetic energy, even the ones that are in solid form or extremely cold. So all these particles are constantly moving. And as the average kinetic energy of particles in an object increase, so more motion, more temperature, a higher temperature. We have common thermometers that rely on expansion. So we use alcohol thermometers now instead of mercury thermometers. And as the temperature rises, then the liquid in the thermometer will expand. So this is true with most substances, that they do expand as they increase. And then a thermometer is just an instrument that uses that to measure and indicate what a temperature is. And then thermostats also rely on this expansion of different substances as well. Alright, so temperature scales. What three temperature scales are commonly used? We've got Fahrenheit, Celsius, and Kelvin. And then we use these for different applications. So the units of Fahrenheit are called degrees Fahrenheit. So the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212. This is the one we're most familiar with. Whereas the Celsius scale gives a value of 0 Celsius to the freezing point of water and a value of 100 degrees Celsius to the boiling point of water. And this is at standard atmospheric pressure. So this does vary a little bit if we were to go up to the mountains in Colorado or go to, say, Death Valley. Alright, so 1 degree Celsius is equal to 1.8 degrees Fahrenheit. So this is the difference between each degree mark on the scale. The temperature at which water freezes differs for the two scales, and this is differ by 32 degrees. So we can convert between Fahrenheit and Celsius using one of these equations. So we use the subscript F to indicate Fahrenheit, subscript C to indicate Celsius. So temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. Whereas if we wanted to find the Celsius from Fahrenheit, it's going to be equal to the temperature in Fahrenheit minus 32 and then divided by 1.8. I think there's another equation that uses 5/9 and 9/5, so those work as well. The Kelvin scale is based on absolute zero, and then absolute zero is just the temperature at which molecular energy is at a minimum. So there's still movement, but it's very small. So 0K on the Kelvin scale is equivalent to negative 273.16 degrees Celsius. So this is a fairly easy conversion after we have got our temperature in Celsius. So temperature in Kelvin is just going to take our Celsius value, add 237 to it, kind of round off this 0.16. So we get a close estimate with 237. So TK here is Kelvin temperature, TC is Celsius temperature.
A number of different temperature scales are in common use. In the United States, the Fahrenheit scale is commonly used for purposes of meteorology and medicine, as well as in most non-scientific areas. On this scale, the freezing point of water falls at 32 degrees, and the boiling point of water falls at 212 degrees. On the Fahrenheit scale, these two reference points are separated by 180 degrees. The Celsius scale is the most commonly used scale for scientific purposes the world over. It is also used for non-scientific purposes outside of the United States. On this scale, 0 degrees is the freezing point of water. 100 degrees is defined as the boiling point of water. The Celsius scale is also called the centigrade scale because it has 100 degrees between freezing and boiling. The Kelvin scale is widely used in physics, chemistry, and astronomy. The size of the degrees on the Kelvin scale is the same as on the Celsius scale. The only difference is in the specification of the 0 point. On the Kelvin scale, the freezing point of water is at 273.15 kelvins, and the boiling point of water is at 373.15 kelvins. This scale was invented after the concept of absolute zero temperature was discovered from the study of gases. As an ideal gas is cooled, its volume decreases linearly with temperature. It can be seen that the volume of an ideal gas would become zero when the temperature reaches minus 273.15 degrees Celsius. This is the temperature that is specified as 0 on the Kelvin scale. It is absolute zero, the coldest possible temperature.
Alright, here we're going to go through some math skills, converting on the temperature scales. So we've got some scenario. Basically, we're starting with 57.8 degrees Celsius. We want to know this in Fahrenheit and in Kelvin. So we're listing what we are given. So we're given the temperature in Celsius, 57.8 degrees Celsius. And then the temperature Fahrenheit and temperature Kelvin is what we want to find. So we're going to write down the conversion equation. So to go from Celsius to Fahrenheit, we're going to multiply, or we're going to use this top equation, and then once we're in Celsius, oh no, we're already in Celsius, sorry, we can use the second equation. Alright, so dealing with temperature Fahrenheit, 1.8 times the degrees Celsius, 57.8. Adding 32 to that, we end up with 136. Nice warm day. Alright, and then for the Kelvin temperature, 57.8 plus 273 gives us this 331 Kelvin. And just a quick note, Kelvin is not actually a degree Kelvin, it's just referred to as Kelvin. Alright, so relating temperature to energy transfer, what makes things feel hot or cold? So the feelings associated with temperature difference results from energy transfer. So when two objects that are different temperatures are touching, energy will be transferred from one to the other. And I could also add that the temperature of objects is going to be transferred from the hotter object to the colder object. So this change in temperature indicates an energy transfer. There we've got the definition of heat, and this is defined as the energy transfer between objects that are at different temperatures. The transfer of energy as heat always takes place from something at a higher temperature to something at a lower temperature. So the greater the difference in temperatures of the two objects, the faster the energy will be transferred as heat. Thanks for listening.